You know some of these from level 2. Have you all done level 2 organic chemistry last year or before? Yes. Okay. Yep. Okay, so Caleb, you haven't. So you're going to have more learning because 9 of these should be familiar if you've done level 2. And so you just have to learn about 5 more, whereas you're going to have to learn all of them as new. Right. We call something an alkane if the molecule only has carbon and hydrogen and there are only single bonds. Okay, so single bonds between carbon and hydrogen atoms only, no other ones. And so as an example here, I've got propane. We'll explain the pro just now, but you can see it ends in ane because it's an alkane. Okay, alkene, so it's called propene. So the functional group matches the name, the ending of the name, and we recognize it by the double bond, and it's a carbon-carbon double bond. You're going to find other ones where it's carbon-oxygen double bond, but this one's a carbon-carbon. A haloalkane is anything that's with a halogen. So what halogens do you know? Just checking. If you want to type them in, what halogens do you know? Just give the symbols. So I can see some of you are typing. Right, fluorine, chlorine, bromine, iodine. Yep, all of those. So here's one for chlorine. And notice the way it's named. It's haloalkane, so it's chloropropane. So it still ends in ane. It's based on an alkane. If you had a molecule with a double bond and a chlorine, then it would be chloropropene. Okay. So that's the haloalkane. Alcohol. Now, oh sorry, I should have highlighted these, the double bond, the chlorine bonding to a C, and halogen, so that's just a tip to help you remember. The alcohol has the C double bonded to an OH. Now, I will say in terms of for the exams, I see the functional group as an OH bonded to a carbon, because you can get OHs bonded to, say, sulfur or something else in organic chemistry, but the examiner last year marked you down because you had to circle something, and they marked you down. If you circled it like this, you had to just circle the OH. So I would, if you're having to circle something in the exam, circle the OH, but state somewhere that it's the OH has to be bonded to the carbon. That sort of covers all bases, because sometimes you just have to go by what the examiner wants, and even if you don't agree with their chemistry. Okay, does that make sense? Okay, right. Now a way to remember an OH for alcohol is there's the COH in the name, so hopefully that'll help you remember an alcohol is a carbon with an OH attached. Okay, and an amine. So if there's a bit of noise, we've got a teacher leaving for 6 weeks, so there may be a bit of, yeah. Don't worry. Okay, no, don't worry. Okay, so if you've got an NH2 group or an NH or a nitrogen of some sort attached to a carbon, that's an amine. So if you think of the Ni for nitrogen, or something like that, that'll hopefully make you remember. An amine contains nitrogen. Any questions about these functional groups so far? If you've done level 2, they should all be familiar. So you all okay? Yep. Okay. Right. Now, these are the new ones you have to learn for level 3. We have what we call a carbonyl carbon, which is a carbon double bonded to an oxygen. So it's not like an alkene carbon double bond. This is a carbon oxygen double bond. So this, we have the C double bond O. Now, depending on what else that carbonyl is attached to, gives it the different type of functional group. So if the carbon is attached to a hydrogen and an alkyl chain, which is this bit over here, it's an aldehyde. Okay, and the ending is L. Very similar to O, so please make sure that when you write, you're very clear that you say, for instance, saying methanol and not methanol, because you don't want to be marked down just because your writing isn't very clear. So just make sure you're very clear that it ends in L for an aldehyde. If the carbonyl group is bonded to two alkyl groups, as over here, then it's a ketone. Okay, so just highlighting those, and the ketone, O for oxygen, is one way of remembering it. Okay, now you came across in level 2, hi April, you came across in level 2 the carbonyl group. Do you know what functional group it was in? If you think of your level 2. Yes, the carboxylic acid, correct. So these I've separated from the carboxylic acid one because the carbon here is attached to something that is less electronegative than it. So carbon has an electronegativity of 2.4, hydrogen is 2.1, and of course carbon's also 2.4. So perhaps I should say these two are separated from carboxylic acids because they're attached to something that's got the same electronegativity as the carbonyl carbon or less. So they react differently. If I go to the carboxylic acid and derivatives, this is now like a separate family from the aldehydes and ketones, because what is that carbonyl carbon attached to? A more electronegative element, or the same or less? More. So we've got oxygen, which is 3.5, oxygen, which is 3.5, nitrogen, which is 3, chlorine, which is 3 as well. So if it's attached to something that's more electronegative, it will react differently than the other ones. So that's why I've bunched them separately. So let's go. If you've done level 2, hopefully you'll recognize that that's a carboxylic acid. Okay, and it ends in oic space acid. Did you notice in all the ones before we never had a space anyway? If I go last viewed, or if I just go, propanol, it's all one word, propanone, it's all one word. All of these, can you see, they're all one words. There's hyphens in them, but it's all one word. If I very quickly go to the next one, when we have the carboxylic acids, we can have spaces. So there's a space between propanoic and acid. In the ester, there's a space between methyl and propanoate. So we sort of like separating it out. That's the acid part, and this is the other part. This is the methyl part, this is the other part. With chloride, this is the chloride part. So there's a space between propanoyl and chloride, and that's the other part. Of course, there always has to be an exception, and the amides are written as one word. You don't have a space there. You don't say propan and then space amide, just to be difficult and break the rule. Okay, so carboxylic acid, the ester, the amide, and the amide. One way to remember the difference between an amine and an amide, particularly if you haven't done level 2 organic. Think of the amine, it's got that N in for nitrogen, and the amide, think it's got it sounds very similar to amine, so it must be a similar thing, but the D is for a double bond. So that may be one way of remembering. The amide has the double bond, and the amine is without the double bond. Do you think that'll be helpful, a way of remembering? Yep, okay. And then you've got the propanol chloride. Now those you do have to learn off by heart. Okay, it's just one of those things you're going to have to sit there and learn. Make flashcards or something. So let's see how quickly you've learned all of that in the last few minutes. What is the first functional group here? Who would like to type it down? Alkene, correct. What? Oh, sorry, I've clicked by mistake. So the second one is an ester. Okay, what about the third one? A ketone, well done. Okay, what about the fourth one? Carboxylic acid. Okay, April, I'm glad you've done that because it depends on what you focus on. Like some people just seem to focus on that OH and then they think alcohol because it's got an OH. But with an alcohol, the OH is bonded to a carbon that's only bonded to other carbons and hydrogens. If it's bonded to a carbonyl carbon, it's a carboxylic acid. So they're similar, but they actually do have different properties. Okay. Right. What about the fifth one? And now you can see the difference actually, April. If you look at the fourth one and the fifth one. Right, it's an alcohol, and well done, Oliver, secondary alcohol. We'll get into that later on, but you did learn that at level 2. What about the sixth one? Acyl chloride, correct. So it's a chloride bonded onto a carbonyl, and so it's not a haloalkane, because a haloalkane would have been bonded just to a normal carbon. This is bonded to a carbonyl carbon. Right, what about the seventh one? The chloroalkane or the haloalkane, great. Okay, and you can see that chlorine is attached to a normal carbon. What about the eighth one? Okay, good. And amine, right. What about the ninth one? Not too sure. So it's bonded to something that's less electronegative to it, so it's separated from that carboxylic acid and derivatives group. There's this, yes, aldehyde, well done. I think it's helpful if you sort of group things in your mind, because then it's sort of, I don't know, I love order and patterns and so on. So the less electronegative or same electronegative are the aldehydes and ketones, and the carboxylic acids are the more electronegative ones that are bonded to the carbonyl carbon. Okay, so that's aldehyde. Okay, and what about the last one? The amide. Okay. Right, so as I say, just keep on learning and make sure you get to know them well. Okay. Now that you know the functional group, you can start cracking the code on naming. So IUPAC, particularly for simple molecules, has very clear-cut rules. When you get very complicated ones, the rules become extremely complicated too, but you don't have to deal with the simple ones. So I've tried to color code it there. So you focus always on the end first. By end, I mean end of the name, not end of the molecule. And the ending is ol. So what sort of functional group would have ol in the name? Alcohol. Okay, and that is the key functional group. In this molecule that I've given you, there's only one functional group in there, and that's the alcohol. You will be expected to name compounds with more than one functional group, and we'll do that as well. So you look at the molecule and you see, right, I've got an alcohol, so my end of the name will end in ol. Okay, the next thing you do, so the end of the name gives the functional group. The next thing you do is you look for the parent chain, that longest continuous chain, so you can draw your finger along it that includes the functional group, where you don't have to lift your finger to hop from one end to the other. So you can't sort of go, right, I'm going to go over here, and I'm going to go down, and then I'm going to hop to there, okay? Or you can't go, I'm going to go to here, go down, and up again, and along. It's got to be continuous. You can't backtrack, you can't hop or anything. So your longest chain is either along here or down there. In each case, it would be 4 carbons. But we're just going to go for the straight one. And can you see in orange, I've got 4 carbons in that longest chain. So for those of you that have done level 2 chemistry, if I've got 4 carbons, what prefix do I use to show 4 carbons? Bute. Okay? I know it looks like but we say bute. And it comes actually from that smelly acid, butyric acid. That's where we got the name bute from for 4. Because they analysed butyric acid some time back and the name just sort of stuck. And bute now means 4. So 4 carbons, so it's bute. Right. That butane, okay, that in black, that is the code to say that this is based on an alkane and not an alkene or an alkyne, which is a triple bond. So if I had a double bond in here, it would have been butene 1-ol, okay? But because I've got an in there, it's telling me I've only got single bonds. Okay, I can see Oliver's typing, but I'll wait till he's finished there. Right, now we look to see where things are on this longest chain. We've got the sort of overview, but now we've got to go in on the details. So the longest chain, the functional group always has to be the lowest number on the longest chain. So it's on carbon 1. So we start numbering from here, the right going to the left, rather than the left going to the right and making this carbon 4. Okay, it has to be the lowest one. So we look to see where's the OH. It's on the first carbon, so I have to say where that alcohol is. So we know it's on the first carbon and not on the second one, and so on. Okay, if there's no other way of putting the double bond anywhere, there's no alternative, we don't have to put that number in. So like propene, I don't have to say 1 propene. It's actually incorrect really to say 1 propene, because the double bond can only be between the first and second carbon in propene. There's no other option. Okay, right, then that purple and blue one we haven't sort of counted yet, and that's we consider a side chain. So once you've got your parent chain, you look for anything that goes off it. Okay, so I've got one side chain, and that aisle over here tells me it's a side chain. So it doesn't end in N or EN or something like that. That aisle says it's a side chain. And how many carbons have I got in my side chain? 1. So we use meth. And that word meth comes from methane. You know, they called it methane before they knew it had 1 carbon in it. Okay, so that's a side chain, and then we count the carbons. There's 1. And then the final thing is we've got to say where that side chain is, and it's on the 3rd carbon, so we put the 3 in there. So that's the code that we use when we make our UPAC names. Okay, so always functional group at the end, and it gets the lowest possible number. You look for the parent chain, and then you look for the side chains. So this is just a reminder about the meth, eth, prop, bute, pent, hext, hept, oct. That's a new way of counting. So you're going to have to count 1, 2, 3, 4, 5, 6, 7, 8, and meth, eth, prop, bute, pent, hex, hept, oct. As I say, these are different because they were based on compounds that were given names. So as I say, this comes from butyric acid. This comes from methane. This comes from ethanol. I mean, before they knew it had 2 carbons in it, it was called ethanol. And then prop, I can't remember. I think isopropyl alcohol. I can't remember where prop comes from. But otherwise, you can hopefully see from your maths, pent is 5, hex is 6, hept is 7, oct. You know, an octagon, a hexagon, I think you sort of can see where these numbers come from. Okay, so one way of remembering it is meet Ethan, professional butler, or the other one is must eat peanut butter, if you want that one. Whatever way that helps you remember it. Okay, if you've done level 2, hopefully you know that well. Okay, right. Now there's also a third way you've got to learn to count. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then meth, eth, prop, but, pent, hex, and so on. Then there's also the mono, which you don't always use, okay, very rarely, but it's di, tri, tetra, penta, hexa, hepta, and so on. This is the number of side chains or the number of functional groups. So this naming we use in the number of carbon of atoms in the parent chains and side chains. This di, tri, tetra, etc. we use for the number of functional groups, because we could have 2 alcohol groups in a molecule, or 3, okay? And then we don't talk about propanol, because the prop means 3 carbons. So we'd say triol, meaning I've got 3 carbons, 3 alcohols. Does that make sense? Right. So this numbering for number of side chains and number of functional groups, this one is for the number of carbon atoms only. Okay, so as I say, learn those prefixes that I just had there, the meth, eth, prop, and the di, tri, tetra. Look always for the functional group. That's always the first thing you do. Okay, because that determines the chemistry, so it's the most important bit of the molecule. Then you look for that parent chain, that longest continuous chain, and it must contain that functional group. Then you look for those side chains. Then, now this is what we'll spend some time on. If you've got more than one functional group, you can't just decide, oh, I'm going to put the alcohol first and then I'm going to put the alkene or something like that. There's a particular pattern you have to follow. And again, that's learning off by heart. And then the dominant, the most important functional group always gets the lowest number. Okay. And then the final thing is just little tweaks. The convention is if you've got a number and a letter, like 1 methyl, well, you can't get 1 methyl actually, so 2 methyl, then it's 2 hyphen methyl. So it's to make it one word. If I've got 2 numbers together, I put a comma between them. So it'll be 2 comma 2 hyphen dimethyl. And then I have no spaces between the letters, apart from those exceptions you saw under those carboxylic acid derivatives. The acyl space chloride, the ester, there's a space on there, and the carboxylic acid, there's a space. So I know this is a lot to take in, but just as I say, the key thing is to check and check and check again. So let's go through all these rules and we'll name these. So assuming we know the prefixes, what is the first thing we do? We look for the functional group. And what's the functional group? An alcohol. So it's going to end in ol. Okay? Then we look for the longest chain. Can you work out how many carbons are in the longest chain? 6, correct. Now what is the prefix we use for 6 carbons? Hex. So we know it's going to be hexanol as an overview, but of course we've got to say where that OH is, and we've got to look for the side chain. So there's my functional group. Now I start numbering my chain, and I go 1, 2, 3, 4, 5. Why did I start over here by the carbon? Quite a few of you typing. Okay, up. Yeah, because the OH has to have always the lowest The functional group always has to have the lowest number. So I can't start numbering from the left. Yes, it's closest to the ol. And then the final thing is I've got to look at the side chain, and there's my side chain. So it's on the 4th carbon. So the name would be 4-methyl. So remember, between a number and a letter is a hyphen. No spaces between the methyl hexane. Okay, it's all one word. Now I'm going from a letter to a number, so I put in a hyphen, because I've got to say where that OH is, and then another hyphen, ol. So, next one, what is my functional group? Amine. So we know it's going to end in amine, okay? And again, we then look for the longest chain, and it is 6 again, because I was focusing on just the functional groups here. So we know it's hexane amine, okay? And we've got the same side chain over there. So it's going to be more 4-methyl hexane, and my amine is on the first carbon, 1 amine. So nearly exactly the same, it's just the functional group is different. Okay, and here's one now where I've taken the NH2 and I've replaced it with a CH3. So what sort of functional group have I got here? An alkane, and it's 7 now. Yes, so that was a trick. So well done, Caleb, for spotting that. So now, so I know I've got 7 carbons, so I know it's now going to be heptane, okay? But I need to work out where that side chain is going to be. So I can either count 1, 2, 3, 4, going this way, like we started, always on the right. But if I do it from the right, it's going to be on the 5th carbon, okay? And if I number it from the left, then I've got it on the 3rd carbon. Which one is the correct one? 5-methyl heptane or 3-methyl? 3, correct, the lowest number. So if it doesn't matter about the functional group, you go to the lowest possible side chain number. So this would be 3-methyl heptane. Okay, right. So here we've now got a carboxylic acid. Sorry, I should have actually asked you that. Okay. Now the carboxylic acid is always on carbon 1. Can you see the carboxylic acid can only, and the same thing for an amide, the same thing for a, sorry, that's a ketone. So the acyl chloride, the amide, the ester, the carboxylic acid, it can only be on carbon 1 because it's only got one other bond it can bond with. Okay, so April, you had the, how is 1-methyl more important than another in the side chain? You choose which one is the lowest. Okay, so CH3 is methyl, that's correct. So if I had, let me just go back a bit. I'll just take that. So this is my longest chain. Okay. Now, if I only had this side chain over here, we'd numbered 1, 2, 3. If, however, this hydrogen over here was a methane as well, then actually then it doesn't matter because it would be 1, 2, 3, okay, 4, 5, or 1, 2, 3, 4, 5, okay. But if this one was a methyl as well, then it would be 1, 2. And then you'd number it from the right going to left. So you always find the side, or number it so that the side chain is the lowest. Doesn't matter which side chain, if they're both alkyl. So if it's a methyl or an ethyl or whatever, you just look for the lowest one. We will look at examples. I think that might be the easiest. So here, both methyls are side chains. Yes, if this hydrogen was a methyl, then I'd have 2 methyls. So we will look at examples. You can never have 1 methyl. This can never be a side chain because it's part of the parent chain. So if you ever make a name 1 methyl something, unless it's part of an ester, you've made a mistake. Okay. Right, so I'm just going to go into, actually let's go through this quite quickly, I think. So basically we've got a carboxylic acid and we've got 6 carbons, so we know it's going to be hexanoic acid with a methyl on the 4th carbon, so it'll be 4-methyl hexanoic acid. But notice in this case we don't put the number for the carboxylic group because it can only be in carbon 1. It can't be anywhere else, because carbon only has one bond that it can bond with. This is an amide, and the same thing. The carbon can only bond to one other, so this will always be carbon 1. Okay, so this is going to be 4-methyl hexane amide. So same thing, we don't have to put the number down. Remember, for the alcohol we did have to put something down. This is a ketone. Now can you see this carbonyl carbon can be bonded to this carbon and to another. It can form 2 different bonds. So I can have a carbonyl here, I could have a carbonyl here, I could have a carbonyl here. So do you see my carbonyl in a ketone can be anywhere, unlike an amide or carboxylic acid. So for a ketone I have to say where it is, unless it's propanone, because it can only be in the middle in propanone. So there's my ketone. I number it where I give it the lowest possible number. I've got a side chain, but I count from the right because this 2 must be the lowest one. So it's 5-methyl heptane 2-O. So I've got the number for the side chain and I've got the number for the functional group in there. Okay, now quite a few of you are typing. Is it possible for ethanone? No, because the carbonyl, it's like an alkene. You can't get methane because you've got to have a carbon-carbon double bond. So for a ketone, you've got to have a carbonyl attached to 2 other carbons. So the smallest ketone is a 3-carbon chain. Okay, right, so here's a more complicated one. You won't get something like this in the exams or anything like that. I'm just doing this to sort of prove the rules. So this is an alkane. So I've got no functional group to guide me of what's the lowest. So I've got to just simply look now for the parent chain and then see what's the lowest possible way of numbering. So, okay, remember the parent chain doesn't have to be in a straight line like we've been having. It must contain the functional group, but in this case we don't have a functional group. And yeah, the longest continuous one, that's already said. So I could draw a line straight across, but that's only 7 carbons. If I went down like that, that's only 7 carbons. If I go down like that, again I've only got 7 carbons. Oliver's already got to it. He's found one with 8 carbons. So well done. Okay, so that is going to be your longest continuous chain. Okay, now that we've got your longest continuous chain, we know it's going to be octane, and now we must just put in all the other bits. So there it is again, I've removed all the other bits. Once when we start numbering, we look for this functional group. If there's none, we look for the side chains. So the first side chain must be the lowest. So if I circle them now, okay, if I go here and count that way, I've got a methyl group on this carbon. So it means on the second one. If I count back, so 1, 2, 3, 4, 5, can you see my first side chain is going to be my 3rd carbon. So do I count from the left or do I count from the, do I do the orange numbers or the green numbers? Orange numbers. Okay, right. So it doesn't matter where all the other ones are, you just go for what's the first lowest one. So we know we've got to count from here, and now we just look for the rest. I've got a methyl here, I've got a methyl there, I've got a ethyl there, ethyl there, a methyl there, and a methyl there. So I've got 1, 2, 3, 4, 5 methyls and 2 ethyl groups. And You were pretty on to it, Caleb. There's just one thing or two things you didn't quite get right. Okay, correct. You've got to say how many side chains. Remember, say the meth prop is how many carbons. You have to use a di-tri tetra penta hexa for the number of side chains or the number of functional groups. So I've got 5 methyl, so it's pentamethyl, and I've got 2 ethyl, so it's diethyl. And I have to put every single number in, as Caleb did there. Then one other thing, because I said Caleb had made 2 mistakes, the other one is you do it in alphabetical order. So what comes first in the alphabet? E in ethyl or M in methyl? E in ethyl. So the ethyl actually comes before the methyl. So even though the methyl's on the lowest one of number 2, we write the ethyl first. So it's 5, 5. Okay, remember the comma between 2 numbers. So we've got an ethyl on this carbon and another ethyl on this carbon, so we show it. Diethyl, and then 2, 3, 4, 6, 6 for this one, hyphen pentamethyl octane. Yep, hyphen between numbers and letters. So commas between numbers and hyphens between numbers and letters. Okay, so you're never going to get something that's complicated, but I hope this sort of proves the rule of how we write things and how we number. Okay, and then as I say, every side chain must have a number. You do alphabetical order, so like chloro also will come, if you had a chloro side chain, it would come before the ethyl, because C for chloro is before E for ethyl. Okay, and then as I said, hyphen, comma, and no space. And we've talked about the exception, those 3, ester, ester, acyl chloride, and acid. Okay, now we're going to get to the specific functional groups, because there are some little tweaks. Halogens are like any other side chain, like a methyl. So they're not more important. So if I had a chloro and a methyl and so on, you don't have to give chloro the lowest possible number. You treat the halogen just like a carbon side chain. The only difference you're going to do is chloro starts with a C, so it'll come before an ethyl in terms of writing the name down, but not in terms of the number. Okay, aldehydes, carboxylic acids, amides, acyl chlorides, always on carbon 1. I think I've said that already. Esters are written in 2 parts, and we'll look at that in detail, because it actually comes from an alcohol and a carboxylic acid. When we do the reactions, you'll see that. So it's like alkyl alkanoate, that's from the carboxylic acid. And then there's that priority list, okay, which you're going to have to learn off by heart. Okay, so let's have an example here. Can you see the chloro group over here and the chloro group over there? So when I number it, I don't have to say, oh, my functional group is a chloro. I've got to make sure that this is the lowest possible number or that's the lowest possible number. It doesn't matter. You treat it exactly like a methyl or an ethyl. So we number it the same way. We start counting because this methyl is lower in carbon 2 than if we were counting the other way. Okay, so there are all the side chains. We've got octane, and we've got 3 methyl groups and 2 chloro groups. So it would be 3, 5 dichloro, di for 2 chloros. Chloro comes first because it starts with a C. And then 2, 4, 6 trimethyl, tri because I've got 3 methyls, and then octane. Okay, do you think you've got it in terms of finding the parent chain, looking for side chains? You are welcome to draw on the exam paper and draw on things that, you know, use a pencil, these are my longest chains, circle my side chains, you know, do that so it's just clearer to you. Okay, let's look at esters. Yep, so just, but I mean, if you draw on it, it'll make it come clearer. And also just always check. It's very easy to make a careless error because you've miscounted a carbon. I mean, I've done it. It happens very easily. Okay, so, oh, sorry. The aldehydes, carboxylic acids, and amides, it's always on carbon 1, and we've already discussed this, so I'm not going to really spend more time on it. We still put the chlorose, but instead of numbering from this side like we did before, we number from the functional group, and it's carbon 1, and we don't bother putting it in because it can only be carbon 1. Okay, 2 methyls, so dimethyl, 2 chloros, dichloro. Okay, and just pointing out in this name there is a space because of the carboxylic acid. Okay, esters. Now, one way of remembering is A comes before C in the alphabet, so you always write the alcohol part first before the carboxylic acid part. It's one sort of way you could remember. Okay, so here's an ester. Now, the functional group for carboxylic acid is the C double bond O, OH, isn't it? So what part comes from the carboxylic acid? This one that includes the C double bond O, or this one which does not include the C double bond O? The first one. So the one that contains the C double bond O is the one that is from the carboxylic acid. So this we name second. That's still carbon 1 of this part. And this we name first. And this is carbon 1 generally. Okay? So I've got 2 carbons. So this is going to be, would anybody like to have a go? 2 carbons in a chain and F. So it'll be ethyl. Okay, because remember it's alkyl, alkanoate. So it's ethyl. Okay, now we do this part. So it's 1, 2, 3, 4, 5. So very close, but we're at 5. 1, don't forget the carbonyl carbon. So it's 1, 2, 3, 4, 5. Okay, and then because this is carbon 1, it's going to be 1, 2, 3. I've got something on the 3rd carbon and then something on the 4th carbon. So Caleb, I'm glad you're going for this because it actually helps the teaching because everybody's now learning and remembering this is carbon 1, so we can't number from this side. Okay, so basically look for that functional group. The part that is not attached to the double bond is the alcohol, and the other part with the double bond is the carboxylic acid. So it's ethyl and then 4-chloro, 3-methyl pentanoate. So once you've practiced, it's actually very easy, but you've just got to have that practice. So it's probably blown your mind at the moment, and unfortunately I can't mess around too long because I want to move on. But do you think you'll look for the part that doesn't have the carbonyl and think of alkyl, and then the part that does have the carbonyl is the alkanoate, and it's always A before C. Yep. Okay. Right, and there's a space. So esters have the space. It's to show there's this break over here. So this is not directly connected to that. It's connected by this oxygen, and that's why we have that space. Okay, so we don't have that much time, so I'm going to go through this very quickly, but if you look over here, what is the functional group of this compound? Ester. So what is the alkanoate part? The left part of that molecule or the right part of that molecule? The left. Okay, so it's going to be pretty much propyl, and then it's got a side chain in there, so it's 1, 2, 3, 4, 5. So it's propyl. There's a pentanoate, but with a side chain. So propyl space 4-methyl pentanoate. What is this functional group for number 2? Aldehyde. So it's going to end in L. And it's always on carbon 1 for an aldehyde, so we don't have to say where that one is. I've got 2 side chains, so it's 4,4 hyphen dimethyl pentanal, because it's 1, 2, 3, 4, 5 in a row. Okay, what is this functional group? And this is a bit of a tricky one, so let's see what you go for. Ester. Well done, Caleb. It is an ester. I know a lot of people think, oh, it's an aldehyde, and yes, it is, but because it's got that O, it's an ester, and it'll react like an ester. You can't say it'll react like an aldehyde, because it won't. It'll react like an ester. So what we've got, oh, okay, sorry, I meant to say, be clear in your writing about the L and ol, so you get marked down. Okay, so that's an ester, that's the side chain, so it'll be ethyl methanoate. Okay, then that is what functional group? Ketone, correct. So remember, we have to say where ketone is, the carbonyl, and so we just count along. We've got, I think, 6 there, and it's on the 3rd one, so it's hexanthreone with all the hyphens and so on. This is an acyl chloride, so I'm just looking at the time, acyl chloride, and it's got a chloro side chain, but this is the dominant one, so we name it as oil chloride. So it's 3-chloro-propanoyl, so it's 1, 2, 3, that's where the prop comes from, oil chloride, and there's that space there. And this is what functional group for number 6? Ester. Right. And so is the left the alkanoate part, or is the right the alkanoate part? The right. So this is ethyl, and that would be propanoate, because I've got 1, 2, 3 carbons. Okay, ethyl propanoate. Does the order of carbon matter in an ester? Yes. You mean where you can have the ethyl on one, sorry, you can have the alcohol part on the left or on the right. It doesn't matter. I mean, these molecules, you could have it going up and going down. Okay, yep. So in space, those molecules could be in any direction. But when we name them, the alkyl part is always written before the alkanoate part in the name. But the molecule itself could be twisted in any order. So it could be, you know, the alcohol part on the left or the alcohol part on the right, in terms of if you drew the molecule. Okay. Right, so last thing is the priority order. Okay, so carboxylic acid, and you're never going to get something, well, I really don't think you would, where you've got to distinguish between an amide and an acyl chloride or anything like that. You know, you just get one of those. So the carboxylic acid and the derivatives comes first, then an aldehyde, then ketone, then alcohol, then amine, then alkene, and then alkyl. And remember, I said the alkyl and the halogen are the same, so that's why I've got a comma there. A methyl is not more important than a chloro. They sort of on the same level. Okay, this order is based on the reactivity. So because the carboxylic acid is more reactive, it's the dominant functional group. If you're going to have a molecule that has a carboxylic acid functional group in it, it'll act like the acid more than it would act like an alcohol or an amine or something else that's on there. Okay. Yep, so this, yeah, they'll always be in carbon 1 for the, yep, so in terms of the name, the dominant functional group will always be at the end. Now what happens if you've got a carboxylic acid and an alcohol in the same molecule? That's when you use this. Okay, so if I've got a carboxylic acid with an alcohol, I don't go oleic acid, I go hydroxy, because it now is a side chain. So aldehydes and ketones have the same name, oxo. Okay, you know by the numbering whether it's an aldehyde or a ketone. Okay, but otherwise you'd call it oxo. And again, I really don't think they're going to give you an aldehyde together with a carboxylic acid or a ketone with a carboxylic acid. If anything, they'll give you a carboxylic acid with a amine, because proteins are like that, and you will get proteins. You could get a carboxylic acid with an alcohol, like lactic acid. You could be asked for the IUPAC name for that, or perhaps with an alkene, something like that. Okay, so the best thing is just to do some practice. So we've got 6 minutes. So here I've got an OH together with a carboxylic acid. This is the dominant group, so it's going to end in oic acid, and this will be carbon 1. So that's why I say you've got to learn the order, because the dominant one gets put at the end of the name and it becomes the lowest possible number. So it'll be carbon 1 in this case. Okay, this is a side chain, so the OH becomes hydroxy on the third carbon. So it'll be 3-hydroxy, and then it's 1, 2, 3, 4 butanoic acid. Okay, so that's just 3-hydroxy butanoic acid. Okay, let's do some more. Now, I'm putting these out there, but really, I have never seen anything like this in the exam paper, so you wouldn't get something like this, but just so that you know the ordering of things. Here I've got an aldehyde with a carboxylic acid. Here I've got a ketone with a carboxylic acid. So I put the dominant one first. Okay, that's the dominant one. That's the less dominant one, if you look at the order. Okay, so this would be 3-oxopropanoic acid. So if you've only got 3 carbons in the chain, and the oxo is on the third carbon, it's going to be on the last carbon, which means it has to be an aldehyde. So by the numbering, you know this is an aldehyde. Here, this is 3-oxobutanoic, so you know the oxo group is not on the last carbon, so it has to be a ketone. But as I say, if this is confusing to you, forget about this slide, because you're not going to get something like this. Okay. Right. You could get something like this, because this is a protein. Well, it's like an amino acid that can be part of a protein. So an amine comes down there. Okay. So that's the most important part. So it'll end in oic acid. Okay. Gets the lowest possible number, which is always 1 for carboxylic acid. So it's 1, 2, 3, 3 amino. So amine becomes amino, butanoic acid. If I had an alcohol, so I've replaced this just with an alcohol and a methyl, the alcohol still dominates over the amine. But is my alcohol now on the first carbon? No. So I've got to say where it is. Okay, even if it wasn't the first one, I have to say where it is. So I get, instead of counting 1, 2, 3, 4, the dominant one has to have the lowest one, so I count from the right. 1, 2, 3, 4, 5. So it's 2-ol, the dominant one goes at the end, and then the other one becomes a side chain. So it's 4-amino pentane 2-ol. So I don't have to give the number here. For carboxylic acid, I would have to give it here. And even if it was on the end one over here, I'd have to still say pentane 1-ol to distinguish it from 2-ol or 3-ol. Okay, here's one with an alkene and the chloro. An alkene is more important than a chloro, but here you just treat it like a halogen. Okay, so it would be 4-chloro. Then there's 2 methyl, so I've got 2 side chains, the chloro and the methyl. And then I've got to say where that double bond is. I've got to make sure it's there and not there or not there. Okay, so it's then but 1-ene. So 4-chloro, 2-methyl, but 1-ene. Does this name make sense? So let me get rid of that other one. Okay, right. Let's do the next one. Here I've got an OH, so it's exactly the same molecule, but I've changed the chloro to an OH. So the chloro was right at the end and the alkene was more dominant. Now I've got an alcohol, this alcohol is now the dominant one. So I have to make the ol at the end. So it's going to become 1,2-ol. It'll end in 2-ol. So it'll now be 4-methyl pent. I've got to say where that double bond is. So it's 1, 2, 3, 4. On the fourth carbon, I've got the double bond. So 4N2-ol. Now, do you notice we've dropped the E for the ene? Yep. Now this is just semantics. Because I've got a vowel there, they don't like having two vowels together. So I don't think you'd be marked down if you said E and E, 2-ol, but normally you don't have two vowels together. So if you're going to have ol, you drop the E. If you have diol, say I had another OH on here, so it'll be 4-ene with an E now, 2, 2 diol, because a D is a consonant, and so I don't have two vowels together. So that's just little things. If you're seeing the IUPAC names and you're wondering why did I drop the E, it's because of that. I don't want two vowels together. Okay, right. I'm just wondering how many slides I've got to go through, because I think I'm going to. Let's just do this slide and then finish. So here we've got, what's the main functional group between these two? The alcohol. So it's going to end in ol. And I count not from carbon. Oh, sorry, no, hang on. It's not going to be the alcohol. It's not going to be the alcohol. It's the aldehyde. Remember, it's carboxylic acid, then aldehyde, then ketone, then alcohol. Okay, so this is going to be the N1 carbon 1, and this will be on carbon 4. So it's going to be 4-hydroxypentanal, and I don't have to say where the aldehyde is because it has to be on the end. Okay, here, okay, this is what sort of functional group for number 2? It has a C double bond O, but what is this one? Okay, that's just so you have to look and check. With organic, people either love it or hate it, because if you sort of sloppy, you don't do well. You've got to keep a very sharp eye. This is an ester. So what side is the alkanoate part? The right or the left? The right. So that is my side chain. Now, you could number it, and I'm wondering if, so this would be this would be propane 2-ol ethanoate. I'm just trying to think of a way of writing it. So it's 1, 2. It's joined on the second carbon to the oxygen. And that's why it's propane 2-ol ethanoate. But again, I don't think you're going to get complicated esters. I haven't seen actually something like this, quite frankly. Ethanoate. This is an alkene with an halogen, so it's done the normal way where it ends in an alkene. Here it's an ester again, so I'm going to go quite quickly. This is a complicated, now I'm just wondering if I've got this one. Yep, so it's carbon 1, 2, 3, 3-methyl butyl. So because there's only one carbon attached, there's no other side chain, it's 3-methyl butyl. But I'm getting quite complicated ones here. Do the ones in the books, they're less complicated. Again, an ester. I've done lots of esters simply because I should actually take that one out. I really don't think you're going to get things like that. What is this functional group over here? An amide. and I haven't given you anything else, so it's just hexanamide, and then of course it's got the 2 side chains. I don't think, yep, so that's the end of the slideshow. So we'll stop there, and I did go slightly over, so apologies for that.